In the earlier lecture, I talk about Legendre transformation, which relate Lagrangian and Hamiltonian. Now, today's lecture, I will talk about the Hamilton's canonical equations of motion. Right. So, consider the Hamiltonian, and Hamiltonian can be written as it is Q1, Q2, and so on, P1, QR, P1, P2, and so on, PR and T. And this Hamiltonian is related to Lagrangian according to Legendre transformation. And according to Legendre transformation, it is PRQR dot minus Lagrangian, and it is Q1, Q2, QR, P1 dot, sorry, it is not P1, what it is, Q1 dot, Q2 dot, and so on, QR dot and T. These are related to each other, like, let me call it as equation number 1. Now, let us take differential on both sides. Taking differential on both sides, so if I take differential on both sides, then this can be written as TH, and H is a function of, say, it is QR, PR, T, and it is differential of summation PR, QR dot, and it is a summation over R. Minus L is a function of QR dot and T. So it's complete. When we solve their differentials, then they can be written as like this. It is summation over R, curly H over curly QR and DQR plus summation over R, curly H over curly PR and PPR plus curly H over curly T into DT. This is basically this part is equal to this one, and now let me try to open it up, and this must be equal to it is summation DPR QR dot as it is plus PR as it is and DQR dot summation over R here or here, means I simply write down this part and let me open this part. This is also like this term, so negative sign will be there. So minus, it can be written as summation over R, curly L upon curly QR DQR plus curly Ly curly QR dot DQR dot plus curly T over curly L over curly T into DT. This is basically this part which I have written here. So let us recall equation that d upon dt curly L over curly QR dot must be equal to curly L over curly QR. So that means curly L over curly QR dot P written as d upon dt into PR, because this is basically PR. That's what we know when we talk about canonical in the earlier lectures I talked about it. Yeah, in the lecture I talked about it in the first lecture of this section, right? Because this is a conjugate momentum. So that means, let me try to look at this part, curly L over curly QR and curly L over curly QR dot. So that means this part is basically equal to curly L over curly QR is basically, it is PR, and this is curly L over curly QR, it comes out to be PR, curly L over curly QR from here, because it is PR dot, right? That's what I'm getting, because it is PR, right? So if I use this, then it is PR dot, and this is simply PR. So if I use this, then this equation can be rewritten as like this. It is summation over R curly H over curly QR dqr plus summation over R curly H over curly PR dpr plus curly H over curly T into dt. It must be equal to summation over R dpr QR dot plus summation over R PR dqr dot. I opened this and it is minus summation over R PR Q dqr plus PR dqr, and okay, it is to one thing. Yeah, it is minus because I opened the bracket. It is minus, and minus curly L over curly T, it is dt, right? That's what I am getting here. So now PR dqr, this will cancel out, and if it will cancel out, so that means I can write down, that's okay, I have forgotten the summation here because summation should be there, right? So let me write down the summation here. Yeah, the summation over R. Now let me sum up this result. Now it is summation over R curly H over curly QR dqr plus curly H over curly PR dpr plus curly H over curly T into dt. It must be equal to, I have written this term first of all, so it is negative of summation R, it is PR dot dqr plus, I am writing it here and it here, so it is plus summation over R, it is QR dot dpr plus, sorry, it's not plus, it's minus curly L over curly T into dt. So if I compare the things, so that means this part is sitting in place of this part, and this part is sitting in place of this part, right? And similarly, this is sitting in place of this. So if I compare the left hand side, and right hand side, then what I am getting, that curly H upon curly QR is equal to PR dot with negative sign, right? And similarly, curly H over curly PR is equal to QR dot, and these two equations collectively known as Hamilton's canonical equations of motion. Also additionally, what we are getting, that is curly h over curly t is equal to minus curly l over curly t. That's what we are also getting, right? So this is a very simple way to derive the Hamilton's canonical equations of motion, and these are sometimes simply known as Hamilton's equations of motion. Now, there is other ways to derive these equations, and we will also use or we can also use the variational principle to derive these equations. So in the next lecture, I will use the variational principle to derive these equations. So that's all for this lecture.